All right, here we go. A janitor at a high school believes that if he forgets to place the slippery sign after mopping the floors, that there's a 60% chance of someone falling, slipping and falling. If he remembers to place the sign, there's a 22% chance of someone falling. There's an 83% chance that the janitor will be placing the sign on any given day after obviously mopping the floors. Okay? Draw a tree diagram or some sort of visual representation showing all scenarios. Can we do this as well, comma, including the probabilities? Including their probabilities. So let's see what is happening here. What are we talking about? What are the two events that are taking place here that we're interested in? One is placing the sign, right? Whether or not you place the sign, right? And what's the other event that we're interested in? Whether or not a student slips and falls. Okay? So I will, for A, when it comes to the tree diagram, maybe S stands for sign and F stands for, and this is up to you what you want to use in terms of letters, whatever helps you out. But S is for me the sign and F is falling. Now, which one of these events should be considered first when it comes to sign and falling? Which one of these should be considered first? Putting the sign up or falling and then putting the sign up? Putting the sign up, that's something that we should consider first, right? Having the sign up or not having the sign up, that's what we should start with. So I will say this, I will branch off like this. And let me see if I can zoom out a little bit. So this branch will represent having the sign up, and this branch will consider forgetting to put the sign. Okay. So what are the chances of putting the sign up? Let's go read. You see that it ends, actually, this whole paragraph ends with there's an 83% chances that the sign will be placed. So I will make this branch 0.83. The reason I go decimal is because that it'll make it easier for us to work with later. But you could go 83 over 100, that's fine. Okay. And so if there's an 83% chance of the sign being put up, what is the chance of not putting it up? 17, right? Because it's supposed to add up to 1. So they don't have to tell you both, they just have to tell you one of the branches and you know the other one. Okay? So there's two possible branches we can go off of, right? Let's say we put up the sign. There's a chance that a student falls, slips and falls, and there's a chance that there is no fall. Okay? And now you have to be careful reading the question carefully. It says if he forgets to place the sign, right, after mopping the floor, there's a 60% chance of someone falling. If he remembers to place the sign, there's a 22% chance of someone falling. So if we do put up the sign, there's only a 22% chance of someone falling, which means that there's a what percent chance that someone doesn't fall? Just take that away from 1, right? That'd be 78. Sorry, 88, right? No, 78, we're good. Never mind. Okay. On the other hand, if we go down this branch where we forget to put up the sign, there's also a chance of falling and not falling. What are the chances of falling if the sign is not being put up? Let's go look up here. If it forgets to place the sign, there's a 60% chance of falling. You can't see that right there, right? 60%. So this is 0.6 or 0.60, if you will, which means that this is 0.4 or 0.40. So this is a probability tree diagram. There's only ever two options when it comes to probability: it happening, it not happening. Okay? And so now I want you to write down, I want you to go a step further where you figure out what's the probability of putting the sign up and a student falling. Like, what are these two events here? So this would be probability of sign and falling. This would be the probability of sign and not falling. Here we've got the probability of no sign and falling. We're talking probabilities now, not just the number of ways. Probability of not falling. Sorry, not having the sign up. Oh, I forgot something here, guys. Notation, right? This F here, where my pencil is hovering, should have a little bar on top. Like so. I don't need you to do the following part on a test or on a AC or anything like that, but I will show you that you're going probability of S times probability of F. Okay. This one is probability of S times probability of F not. Then it's probability of not putting the sign up, okay, times probability of falling. And this one is probability of both of them not happening. What's the question? Did you have a question? This is just a fancy formal way of saying what's about to happen, okay? So you grab your calculator and you go 0.83, like 0.83 times 0.22. You multiply them. And there's a 0.1826, like about 18% chance that will happen. Okay? Next, you take 0.83 and you multiply it by 0.78. There's a 0.6474. Your best bet is to leave this as a decimal, folks. That's your best bet. Okay? It makes it easier later. Then we've got 0.17 times 0.6. That is 0.102. And last but not least is 0.17 times 0.4. That's 0.068. Okay. Now, one thing to check here is you want to check if all of these add up to what? You want everything to add up to 1. Okay. That's one way to check. So let's see, I have these numbers on my calculator, so I'm just going to go copy paste. So that one plus this one plus the 102 plus 0.068, and that adds up to 1. So this is a bit of a check, right? Equals to 1, and there you go. Okay, so that is what we're after. If you do not have to show us this part, I would even say I wouldn't mind you keeping that, but I would say this is optional. What we would want to see is the probabilities at the end of these branches here, if we do ask for all the probabilities. Okay. So here you have all possible outcomes based on this story here, on this scenario. Now we can answer a bunch of questions based on this outcome table here, or tree diagram. B is asking, what's the probability of someone falling, right? That's what B is asking for. So probability of someone falling, let me just make sure this is all the way. It's simply adding all the outcomes where you have an F, okay? Falling is right there, and falling is right here. So you have to consider this outcome or this outcome. So I will just show you here, 0.1826 plus 0.102. And that adds up to 0.2846. They don't ask, if they ask as a percentage, obviously you would want to multiply that by 100, but if they don't say anything, this is all you want, right? So I've added the outcomes where someone falls, right? So this branch here and that branch there. C. What's the probability of having placed the sign given that someone fell? So you're going backwards in time almost with this one. Let's translate that. Probability of having placed the sign given that someone fell. That is what this question is asking. Okay, guys, that's the notation for that. So it's asking, like, what is that? What is that probability? And you cannot, guys, you cannot just go grab it from your table, like from your outcome, your Venn diagram. You cannot. You have to calculate that. Okay. 43. So how do we do that? I'm going to take you back a little bit. Take you back in time to page 38. Keep your finger on this page. But at the bottom of this page, I highlighted it in orange. If you have a scenario where B, figure out the probability of B given that A already happened, okay? Look up here real carefully, okay? Which two letters do you see over here? B and A, right? So you see A and B. So that shouldn't surprise you. But which probability is down here in the denominator? Is it the first letter or the second letter? It is the second letter, right? That goes here. That is the key. So I'm going to use this formula to help me figure out what the question is asking for. So let's use this. I've determined already, I've translated the question to the proper notation, which means probability of the sign having been up, given that someone fell, is going to be probability of sign and falling, the sign being placed and someone falling, divided by probability of what? Of falling. That is the pattern. Always, always, always. Okay? The hardest part here is just to decipher what is the question trying to ask, or like which one is it asking for. Okay, so let's figure this out. What's the probability of the sign being up and someone falling? What is that specifically? Look up here. sign up and falling is this one right here. It's that answer right there, 0.1826. Divided by, what is the probability of falling in this case? Yes, we already did that before. If I hadn't done that, then this would be your cue to go find it, right? So this would be 0.2846. And so basically divide these two numbers. 0.1826 divided by 0.2846. And there it is. It's 0.6416 or 64.16%. I'll tell you this. This is always at the bottom of one of these questions if it's on the exam or on a test, and it's going to be worth 1 mark. So if this is not going to like rob sleep, like you're not going to sleep at night because of this one, maybe don't lose sleep over it. But if you do want that mark, this is how you do it. Okay? I'll do one more. You ready? This is where you come in. What is D asking for? Let's translate that. What is the probability of not having placed a sign given that someone fell? See that given? Okay. Can I translate that? I'm going to try to give you a different scenario, different terminology that they would have used. You ready? Another way that they could have phrased this is, hey, someone fell. Like someone called the office and said someone fell, right? What's the probability of not having placed a sign, right? That's another way. So the given means that something happened for sure. We got to go back now and see if the sign was placed or not, okay? So in this case, let's translate that. It's asking for the probability of not having placed the sign given that someone fell. That's what that is asking for. That's what the question is asking for. So given this, okay, if you go home today, don't tell your parents about this, okay? I know you're excited. I know you're like, I can't wait to tell you, right? But they won't appreciate this one, okay? So just hold it, keep it to yourself. I'm just saying that because your faces are telling me like, can we skip this? Okay, so again, the pattern is these two for sure show up on the other side. Okay, that is a given. It's the and. You connect them with the and. So that's the probability that goes on top. At the bottom, which of these goes at the bottom? It's always the second one, the one you've determined to be over here. And that's based on the question, right? Given that someone fell. So probability that someone fell goes here. And I would say this is the one time that notation matters a lot. Do we already know probability of someone falling? Yes, it's 0.2846. So let's go ahead and get it out of the way. It's this one that we need to go find. Let's go find it in our tree diagram. Not having put the sign up and someone fell. It's this one in particular. It's that one case right here. So we go back down, 0.102. Divided. That is 0.3584 or 35.84% chance that the sign was not put up, given that someone fell. Mr. Dirksen, but there's nothing being removed. The first event happens, nothing is being removed. Is this dependent events? Are these dependent events? Does one affect the other? Yes. I think you can just think about it just in logical terms. Like obviously if the sign isn't up, someone's gonna walk and just go, right? Because they don't expect it. You're not as cautious. But let's look at our tree diagram. If the sign is up, is falling and not falling different than if the sign is not up? You can tell they're different, right? They're different. Like falling is lower here than it is over here. Like that simple fact that they're different, falling, not falling is different, whether you go up one branch or the other, tells us that these events are dependent. That the first one affect your second one, okay? So this is also a scenario. That's why I told you if they make you make a question, don't make one of these. Just make one with marbles and cards and you're removing them, okay? Like that's so much easier. But this is another one of those cases that these are considered dependent events. And I have some good news for you. If you, historically speaking, 99% of the time they do something like this. They start you off with, draw a tree diagram with all possible outcomes. And then you know already, oh, okay, I know that I'm supposed to do something like this. And then they're gonna ask me a question or two afterwards, okay? All right, I'm gonna stop here and I'm gonna ask you to go to 44 and try that one. Would you like, I'm gonna pause this here. So do page 44. Here are the answers. Make sure you write down C. It should start with a Venn diagram, not Venn diagram, tree diagram. Hold it. Tree diagram, okay? You should start with it even if I don't ask you for it. This type of question requires that. So go for it.